Start.
Hello everyone. Good afternoon to all of you. In this current pandemic situation, I want to say stay home and stay safe. This webinar is conducted in collaboration with IQAC and Department of Computer Science of Gurudas College. I, Kajuri Bhattacharya, on behalf of the Department of Computer Science, welcome all of you to our 12th one-day webinar on distributed artificial intelligence and agent technology. This is an interactive webinar. You can type your question in the live chat box section. Please do not forget to mention your name and institution name before asking any question. For today's webinar, we have with us our speaker, Dr. Animesh Dutta, and my colleagues, Mrs. Sonali Gupta, and our head of the department, Srijita Chakraborty. Now, I would request my colleague, Mrs. Sonali Gupta, to please read out our principal madam's speech as she is unable to join our webinar due to her busy schedule. Sonali, you can proceed.
Thank you, Kajari. Good afternoon, everybody. I, Sonali Gupta, would like to introduce our respected principal, Madam Dr. Moshumi Chatterjee. Some important official work has prevented her to get connected with us virtually. So, here is a message received from our respected Madam, which I will deliver to all of you present here. The message reads, it is a pleasure to inaugurate today's webinar organized by the Department of Computer Science and IQAC, Gurudas College, on a topic that pupils from all walks of life could start to know about. Our esteemed speaker, Dr. Animesh Dutta of NIT Durgapur, will speak on distributed artificial intelligence systems, a matter that has been developed for applications to vital public facilities. As I can understand, the subject aims to learn and solve problems simultaneously in a correlated way at a various nodes, which are also known as agents located as large number of geographic states distributed over a wide range of spaces. Broad areas of applications are communication network systems such as electronic trading networks, electronic power networks, and public transport systems, to mention a few. I hope this webinar will illuminate the participants with the knowledge of how things work coherently in many important facilities that they use every day. I wish all the success of this webinar. Dr. Moshumi Chatterjee, Principal, Gurudas College, Kolkata. I would thank her for all her support and allowing us to organize this webinar. This is all from my side. Thank you. Kajuri, you can continue.
Thank you, Principal Madam, and thank you, Sonali. We cannot connect our IQAC coordinator, Dr. Tipona Mojumdar, due to her technical issues, but her recording with us. And I request Srijita Di to play. Srijita Di, you can.
Good afternoon. Hope all of you are keeping well in these trying times. On behalf of the Internal Quality Assurance Cell, Gurudas College, I welcome you all to today's webinar. This is the 12th webinar organized by us. Today's webinar is jointly organized by the Department of Computer Science and Internal Quality Assurance Cell of our college. Our speaker today is Dr. Animesh Dutta, Associate Professor, NIT Durgapur. He will speak on distributed artificial intelligence and agent technology. To tell you the truth, I do not have much knowledge about this topic, but it sounds really interesting. We observe many things happening automatically in the digital world, but these automatic occurrences are controlled by certain technology. How? That is the question. I guess Dr. Dotto will enlighten us on such and many other issues. As participants, we have both teachers and students from our college and many other institutions. All are eagerly waiting to learn about this interesting topic. Without further delay, I request to carry on with the proceedings. Keep safe, keep healthy. Thank you.
Thank you, Dipanadi, for this wonderful speech. I know all of you are excited to know and understand what is distributed artificial intelligence and what is the agent technology. So, without any delay, I request our head of the department, Mrs. Srijita Chakraborty, to please introduce our speaker, Dr. Animesh Dutta. Srijita ji.
Thank you, Kajari. It is my pleasure to introduce today's speaker, Dr. Animesh Dutta, who is an associate professor in NIT Durgapur. He has received AACM DUO Professor Fellowship 2020 with Claude Bernard University, Lyon 1, France by European Union. Delegation of Young Indian Leaders to Discover Israel program. Delegation to first BRICS Working Group meeting and Innovation Collaboration Forum on ICT and HPC. He has been awarded Visvesvaraya Young Faculty Research Fellowship Award in 2016 for 5 years by MEITY, Government of India. Many students have completed their PhD under his able guidance and many are still pursuing. From his busy schedule, he has found time to enrich us with such an interesting topic. Without wasting any more time, I would now request Dr. Animesh Dutta to please take over the screen for which we all are eagerly waiting.
Thank you so much, Mrs. Srijita Chakraborty and your entire team. And
Thank you.
thank you so much, the entire team and the administration of Gurudas College for giving me this opportunity to have this webinar in this pandemic situation. So, without further delaying, I am directly starting my topic of discussion today. So, before. Let me share the screen. Okay, so so the today's topic is distributed AI and agent technology. So when the Gurudas College invited me to speak something on our area, so I decided this particular topic, distributed AI and agent technology. I thought this topic may be very relevant to today's context of computer science or ICT, the way people are using smartphones, smart televisions, everything. So everywhere, in some form of automations we are using, in knowingly or unknowingly. So knowingly or unknowingly, we are today the part of distributed AI. Whether you are a computer science people or a non-computer science people, that doesn't matter. It matters that you are either as an user or developer or designer as a part of distributed system. Okay, so that was the main motivation why I choose this particular topic and convinced the administration of Gurudas College to allow me to take this topic. And I will request everybody that though is an webinar taken place through online media, so it is my earnest request to everybody that to have interaction in between the lecture. So if you have any doubts in any slide, without any hesitation, you may ask the questions. I will be happy to answer, because there are a lot of things that I can learn from the discussion. So I don't want to miss that opportunity also. Okay, so so the topic is distributed AI and agent technology. And we have a very dedicated research lab of multi-agent system and distributed computing lab in the Department of Computer Science and Engineering. Many of our students works from master's student to PhDs are working in this domain. So I will start with the motivation scenario, how agent technology and distributed system works in today's world. So let us assume we are moving 2021 and how the computing system or the ICT will looks like to our general requirement. Take an example, a person named as Praful. He has a meeting with his boss. So he is moving, he is driving his car to the office of boss to meet him. And so he is saying that I have a meeting with my boss and I am late. Now, while on the way to the meeting, he received a phone call. The phone call said, your wife had an accident and she is admitted at some hospital in Powai. So suddenly, the moment he received the phone call, so he has to cancel the meeting with the boss and he has to immediately go to the hospital to visit her wife. So what he did, he immediately requested, I should inform my agent to reschedule the meeting. So he has an agent. You can think that agent is a software program who works on behalf of Praful. So I should inform my agent to reschedule my meeting with boss. Once the agent receives the command from Praful, agent start working. It knows who is his boss and the address of boss's agent. So the Praful's agent started negotiating with boss agent to reschedule meeting for tomorrow. Here you see, the Praful does not need to say anything to his agent when is its availability, who is the name, who is his boss, etc., etc. Because all these informations are already there with the Praful's agent. So the moment Praful's agent receives a command from Praful that he cannot join today's meeting and it has to reschedule it. So Praful agents immediately interact with the agent of his boss and they start negotiating to find out the next possible time when both Praful and his boss can meet for the meeting. And they found that tomorrow is the best time for them to meet. So accordingly, Praful's agents inform Praful that your meeting is rescheduled to tomorrow at 5 p.m. Next, Praful says, as I still don't know where is C, that is the wife, admitted in Powai. I should use my agent because Praful doesn't have the knowledge where her wife is admitted after the accident. So again, he requests his agent that you please find out the address of the hospital where my wife is admitted. Praful agents immediately contact a middle agents to find out some hospitals in Powai having recently admitted a patient named as Geeta. Praful agent knows that the name of his wife is Geeta. He is just have an accident and admitted in Powai. So Praful's agent immediately contacts some middle agents, or we should say the hospital's agent, with the question that there is a person, lady, who admitted in one of the hospital whose name is Gita. After interacting with number of agents of the hospital, powerful agents found that your wife is admitted at New Powai Hospital, ward number 9. So immediately after receiving this information from the agent, Praful, so this is one of the motivating scenario that I want to tell. The way computer system, the way autonomy, the way communications is evolving in our daily life, there is no far that when we will see this type of situation, that most of the work which is supposed to be done will be done by our agent. So each person will have a software agent. That agent will do on behalf of its owner. Just like today you have travel agent. What do we do with the travel agent? We have a plan for a vacation, maybe to Simla for 5 days with my family. So I give some information related to my family to the travel agent, some budget, and the date of my holiday. The travel agent start finding the best possible schedule for me, starting from my residence to train booking, hotel booking, then local visit, everything. At the end of the day, this travel agent brings with a schedule and the expenditure that I need to spend. So here the travel agent knows everything, what I need and what possibly I can avail with that much of budget. In the same way, we are thinking of software agent which will work on behalf of us. That is the main motivation behind the today's discussion. So some of the contents that I have for the today's discussion. So gradually I will be trying to discuss very briefly what agent technology, what is AI, how agent technology and AI evolves, and then some of the research areas where presently we are working. So that is our today's discussion main agenda. But again, I am telling, if somebody is interested to more detail, go to the more detail about these things, there are a number of research areas where presently we are working. My PhD students are working. If you feel comfortable, if you feel interesting, you can search the web or my web page. You will find a lot of papers related to this topic, where the agent technology is the main central focus. Okay, so if you see the modern computing trends, you will find basically these 5 trends: ubiquity, interconnection, intelligence, delegation, and human orientation. The first one is ubiquity. According to Moore's law, the computing power gets double in every 18 months. That means with the same price, you will get the double capacity of your processor. And that leads to the use of computers everywhere. Today, starting from mobile phone to television to your microwave, fridge, washing machine, everywhere you have computers. Maybe the computer is not a general purpose computer, is a specific application specific computer, but computer is everywhere. The cost of processor is decreasing dramatically, and that helps to keep computer in every electronic devices. Not only even in electronic devices, if you think of the lowest car that is available in Indian market is Nano, that is also equipped with an MPFI engine, which is a computer inside it, which controls the ratio of fuel and the air mixture. So computer is everywhere. That is ubiquity. The second is interconnection. Today it is very difficult to find a computer that doesn't have network. So that doesn't have network. So the moment you have a computer, immediately we think that it is capable of sending and receiving messages with other computer. Maybe through internet, maybe through Wi-Fi, other or LAN or Bluetooth or whatever means of connectivity is there. But there must have some kind of network. If you think of the global network, that is the internet, that is also very cheap today. So just like the Moore's law, the data is also going cheaper and cheaper. If you see 5 years back or 10 years back, accessing 1 GB data is maybe 100 rupees. But today, through Jio and all this connectivity that provides in India, that is with the 5 rupees you can avail a 1 GB data. So cost of transportation of data over the internet is getting lower and lower. That enables you to connect number of computers with each other. Today we don't keep our music or movies in a computer. Rather, whenever we require, we just simply search on YouTube, or there are a number of websites which provides you these movies, music. You can start online. You don't need to download it. You don't need to save it in your hard disk. So connectivity is so easy. Transportation of or transferring the messages is so easy, so cheap. So computer system today no longer stand alone, but are networked into large distributed system. Apart from that, there are a number of such applications with which we are very much familiar, like banking system, ATM system. Today, the thing that we are doing now, that is also an example of this interconnection. Maybe Srijita told me that there are 150 participants participated in this webinar. So I am giving the lecture from one part of the state in Durgapur, to say as a border area of West Bengal and Jharkhand. There are 150 candidates who are participating across West Bengal. So that is possible only through interconnection of computers. Next is intelligence or artificial intelligence. When you say artificial intelligence or intelligence, it is the capability of computer to do more complicated tasks. It is the capability of computers to do more and more complex tasks. It's a very easy. Most of the institute, most of the organization today use biometric, where they keep your fingerprint. They run some kind of algorithms, programs. When you show your fingers, it can detect whether you are that particular person or not. Accordingly, your attendance is taken. So it is an example of intelligence. You have a collection of such biometric images, and when you put your fingers, it can detect whether this is that person or not. So there are a lot of examples with which today we are habituated with intelligence. Even today, if you go for simple washing machine, it is equipped with an intelligent IC chip. You just put the clothes on the this washing machine. It can detect how much water it needs to take, what amount of detergent it can take. Accordingly, it will start taking it and start washing the clothes. After sometimes, it will give you an alarm that the washing is done. So this washing machine is equipped with an AI chip. The next is delegation. Computers are doing more for us without our intervention. Today's best example for task delegation is Google Car. I mean, not only Google Car, there are a lot of companies which are coming for driverless car. So maybe the next revolution will be driverless car, where the passenger will take a car. There will be no driver in the car. You just need to tell where to where, from where to where you have to go. It will decide by car itself. So it's called delegation. There is another example called fly-by-wire airplane, where you don't have any pilot inside the airplane. Automated cruise control. Fly-by-wire airplane. Human orientation. I mean, 20 years or 30 years back, if you think of computers and today's computers, there is a huge difference between the way we interact. Today, you don't need to be a computer specialist to use a computer. Their graphical user interface or the other medium of interaction is designed so easy way that a person with having marginally education can easily use it. And that's why you can find out everywhere, every person is equipped with a smartphone. Even in his life, he never went to the school, but he can use the smartphone because the interface of the smartphone is so easy. He doesn't need to be a computer specialist to work on it. Even there are number of instruction, number of commands for the system which you can give just by speech. You don't need to write the command, or you don't need to give any keyboard input or mouse input. So we want the computer as if like a human being. The way we interact with one person with another person, in the same way today we are trying to interact with one person with another computer. So person to person is replaced by person to computer. So it's a more like a human orientation, increasing the use of metaphor that better reflects human intuition from everyday life. That is GUI, graphical user interface, speech recognition, object orientation. The way we are interacting with one person with another person, in the same way we interact with computers today. So the evolution of computers, if you see the 100 millions of people today are connected, just like today's example, there are 150 people registered across West Bengal to participate in this webinar. In 10 years back or 20 years back, it was just a science fiction. In 20 years back, if somebody says that there will be a situation in 2020 when people will be attending the lecture or classes online, everybody can attend the lecture sitting at their own pace. You don't need to move from one place to another place. You just sit at your own drawing room, open your machine, maybe in a mobile phone or laptop, you start attending the lecture. So 20 years back, it was a science fiction. Similarly, maybe today's science fiction will come true one day. So that is the way of evolution of computers. So if you see the programming progression, the first starting of computer programming is called machine code, which is fully dependent on machine. You need to know each and every architecture of the machine. And there are some mechanical switches with which you have to write the code, and the codes are 0-1 binary code. So if you switch on the machine, switch on, it reads 1. If you put the switch off, it reflects 0. So by writing the 0-1-0-1 with the switch, you have to write the entire code of the program. And that is also dependent on the machine. That means once you write a program for a particular machine, that program you cannot execute to some other machine, because that program was dedicatedly for particular machine dependent. And to write that particular code or that particular programming language, you need to be very conversant with the lower level hardware architecture of the machine. The next level is assembly language, where you don't need to write the code in machine language like binary 0101, but there are some specific code for each processor. If it is an AMD processor, if it is an Intel processor, accordingly you need to write the code. And for each processor, there are a set of opcode and operand. So you have to remember the opcode, which type of operations you are performing. Maybe you are performing an addition, subtraction, or multiplication. So for each of these operation, you will have a definite code for that particular processor, and you have to use that particular code for that processor. So these are called assembly language. So assembly language is, to some extent, it is independent of machine. So writing a program in assembly language for one machine, you can use the same code to execute the program in other machine if your processor remains or processor architecture remains same. But your computer may be the entire architecture may be different, but if your processor is same, you can execute because the opcode will be same. Next, you have the machine independent programming language, where you don't need to bother about the machine. You can write the code for one machine, sitting at one machine. You take the program from that machine, you can execute that particular program to other machine. So you don't need to bother about the machine hardware architecture. So these are some kind of the earlier program of BASIC, COBOL, Fortran. These are machine independent programming language. And from there, it starts the subroutine. Subroutine is just an advancement of this machine independent programming language, where the big program is split into small subprogram or some function kind of thing. Then you have procedure and function, just like your C programming language, where you can call your procedures, you can define your procedures and function, and you can use the same function in number of occasions. Once you write a function for factorial, finding the factorial of a number, you can use that function in a number of times. You don't need to repeat the same function repeatedly. You just execute that function once you have the code. And gradually it evolves with another design called abstract data types, where not only the existing data types of the program, rather you can use your own data types. You can create your own. So using the existing data types, you can design your own data structure for your own purpose, like linked list, queue, stack. So these are abstract data type. At your own purpose, you can design some data type. After that, you have object, like C++, Java. These are object-oriented programming. So for in object is something like the society or the human, the way we works with the different objects. For example, this telephone may have, we can say this is an object. This telephone is called as an object. It has some functionalities. If I have to call somebody, I need to dial it. If there is an incoming call, I need to take the receiver in my ear. So we can treat this telephone as an object. It has some functionalities. But after that, there is a notion called agents, where we feel that agent is more like a human being, more like an active entity. For object, you have to repeatedly say what you need to do, what method you have to invoke. But when you talk about agents, you don't need to say what you have to do, how you have to do. Just like the example that I have given in the beginning of the lecture, that Praful said his agent that you please reschedule the meeting. That is the thing he said. The remaining activities, agents knows how to do it. So what to do, I have to tell, but how to do that I don't need to tell. That means it's a kind of more abstraction, more autonomy on the object. When we say object, there is no kind of autonomy. Abstraction is less compared to agents. So delegation and intelligence imply the need to build computer system that can act effectively on our behalf. We are delegating our tasks which are supposed to be done by us. Instead of doing us, we are delegating those tasks to our system to do for us. Intelligence imply the capability of doing this complex task. So this implies the ability of computer system to act independently. Independently means I don't need to say repeatedly how to do it. It can do independently. Just like I told the example, travel agent. I just told that I need to go for a holiday vacation for 5 days with my family. These are my family members to Simla. This is my budget. This is the thing that I need to tell to travel agent. The travel agent will make everything for me. I don't need to say how to book the hotel, how to book the train, how to go from my room, house to station, or from station to hotel. I don't need to say everything because the travel agent knows everything for me, what I need to do, what I want. So the second, it implies the ability of computer system to act in a way that represent our best interest while interacting with other humans or system. Okay, so computer system expands, and these issues were not studied earlier in computer system. All these trends have led to the emergence of new field of computer science that is called multi-agent system. An agent is a computer system that is capable of independent action on behalf of its user. An agent is a computer system that is capable of independent action on behalf of its user or owner. An agent is capable of independent action. Agent's action is purposeful. When an agent works, it does for some purpose, some goal in its mind. This is another definition of agent. An agent is anything. An agent is anything that can perceive its environment through its sensor and act upon that environment through its effectors. Automatic air condition. Automatic AC is an example of agent. You tell your AC that my comfortable temperature is 26 degrees centigrade. Now AC starts and it can perceive the environment of the room, and accordingly it will control its thermostat, whether it will heat or it will cool these things. Now, what is multi-agent system? A multi-agent system is one that consists of number of such agents. When one agent is not sufficient, there are number of activities where a single agent cannot do. So you need to have multiple agents which will interact with each other to achieve the common goal. which is not possible by a single agent. So the next term will be coming with the term autonomy. When you say agent, the associated term will come as autonomy, which was not there in the case of object. A system is autonomous if it requires little help from human user. If we don't have to tell it what to do step by step, we don't need to say what to do steps by step. If it can choose its own goal and the way to achieve it. If its behavior is determined by its own experience. If we don't understand its internal working principle, internal architecture. So as a user, as an owner of the agent, I don't need to understand the working principle or working architecture of the AC. It can automatically detect the sense, the environment, and it will adjust its temperature. So that's why it is called autonomous AC, autonomy.
Hello, sir.
Hi, bolo. Hello.
Sorry for interruption.
Hi.
There are some questions that our viewers are posting.
Sure.
Would you like to take the question now or later?
No, now only.
Okay, I'm showing that on the screen.
Okay, should I? Okay.
Okay.
Yeah, sure.
স্ক্রিনে দেখা যাচ্ছে?
হ্যাঁ, difference between subroutine and function, is it?
Yes.
Okay. So as such, there is no big difference between subroutine and function. In some programming language, it is called subroutine. In some programming language, it is called function. But for the user perspective, once you write your subroutine, you can call the subroutine in number of times. Same thing happens for function. For example, in COBOL, Fortran, we don't say function, rather we say subroutine. But for C, we normally say function. But so for the design and so for the concept is there, both remain same.
Now we move on to the next question.
Okay. How to write a neural network for an AI? I mean, I don't understand the question. How to write a neural network?
Okay, next question.
Can I interact with them? No.
No.
Okay.
They only interact with you by posting their comments.
Okay. Next. Sir, how does developer add cognitive sequence in the source code of AI? I will come to this, what the exact question that you are asking. I have the answer for this question. I think that question will be clear once I go through those slides. But if it still remains for these questions, you please ask me the question again, because I have the answer for this question. Once I complete the slide, your question will be, your question will be resolved.
This is the next question.
See, when you say intelligent agents, my next slide will be coming. Is it visible? Hello? Hello?
Hello?
Madam, এটা দেখা যাচ্ছে স্লাইডটা?
হ্যাঁ, দেখা যাচ্ছে.
When you say intelligence, there should be three properties to have a system intelligent or to have an agent intelligent. The first criteria is reactive, the second criteria is proactive, and the third criteria is social ability. If these three criteria fulfills, a particular agent we will say it is an intelligent agent. If one of the characteristics fails, a properties fails by an agent, we won't say it is an intelligent agent. We may say it is an agent, but we cannot say it is an intelligent agent. Okay, I will be discussing more detail about this properties. Next question. Does the image recognition program? This is entirely different area. Image. Okay. Can artificial intelligence ever take the places? This is more like a philosophical questions that you are asking. Can artificial intelligence ever take the place of human intelligence? It's a question, kind of science fiction question, but definitely the answer should be already some of our works being done by artificial intelligence. I mean, for the last few days, I have been using, there is a program called Grammarly. So Grammarly is a software, is of course intelligent software, which can detect your error, English error, grammatical error, spelling error. Even if you have a purchased version of the professional version of Grammarly, it can suggest you which will be the best sentence for describing this particular expression. Suppose I have written something, they have some better option to replace my sentence. So they will give me advice. You can replace this sentence with some better vocabulary or better sentence. So to some extent, of course, you can think that a lot of human works which are supposed to be done by human being are replaced by the computer system. Today, many of you may have the car which is auto transmission. I mean, in India's road, there are a lot of auto transmission cars. You don't need to switch the gear from one gear to another gear. Just you start the engine, you put the accelerator, it will choose the gear automatically. You don't need to say you go for first gear or second gear or third gear or fourth gear. Based on the speed, the road condition, it can detect which gear should be the best option for the time being. Next.
Okay, sir, you can continue the lecture. Okay.
Okay, so the question that somebody asked, that what is intelligent or intelligent agent? So there are three desirable properties for intelligent agent. Desirable properties can be listed: reactive, proactive, and social ability. Reactive means an intelligent agent should respond in a timely fashion to changes they perceive in their environment. Depending on the input from the environment, it will change it immediately. Proactive, intelligent agents can take the initiative to meet their design objective. So there is a difference between reactiveness and the proactiveness. Reactiveness, based on the input, it will change. It will perform the next task. But when you say proactiveness is something different, where you have something in your mind, and based on that, you are performing the action to achieve that goal. You have some goal in your mind, and you are doing some action to achieve that goal. That is called proactiveness. So you don't bother what is happening in the environment or not. Based on the objective you have in your mind, you are performing the task to achieve that objective. The third characteristic is social ability. An intelligent agent can interact with the other agent. Here, the other agent can be agents, or even it can be human being, to satisfy their design objective. Just like in the human society, you can interact with the other agents. One person can interact with the other person. One person can interact with the other person to do some certain works. In an organization, there can be a number of people, maybe one principal, vice principal, head of the department, faculty members, staffs. So there are a number of people working together. and then in number of occasions they need to interact with each other to do the best for the institute. In the same way, you have the social ability. If you can design the agent system such that they can interact with each other, they can interact with a human being, then we will say your system has the ability or social ability. So if these three properties satisfy your system, then we will say it is an intelligent agent. So now the diagram here is an autonomous devices situated in an environment and purposeful. Would you say it is an agent, or would you say in a more one step further, would you say it is an intelligent agent? The answer is, of course, you can say it is an agent, but whether you will say it is an intelligent agent, there is a question mark, because this agent have reactiveness. Depending on the environment it senses, it will switch the heater off or on. So it has the reactive properties, but it doesn't have the proactive properties. It is not goal driven. It doesn't have goal anything in its mind. Neither it has the characteristics of social ability. That's why you cannot say it is an intelligent agent, but of course we can say it is an agent or agent autonomy. So what is an environment? The environment is the entity in which agent is situated. It is in this environment that an agent senses and acts. So if you say, if you see the design of this agent, it has sensor through which it can perceive the environment. So this is the agent. These are the sensor. Through the sensor, it can perceive the environment. After perceiving the environment, it starts some kind of computation. Then it performs some action through its actuator or effectors, and that will affect the environment. So there are some classification of environment. It can be accessible environment, inaccessible environment. If the environment is fully accessible by the agent, then we will say it is an accessible environment. Otherwise, we will call it is an inaccessible environment. Deterministic versus non-deterministic. If for every action of the agent, we know what will be the next step that we can determine, then we will say deterministic environment. But if it is not, then we will say non-deterministic. Static versus dynamic. Does the environment changes by process beyond agent control? When the agent is performing some action on the environment, whether the environment changes. If yes, then we will say dynamic environment. Otherwise, it will say is a static environment. Then we have episodic and non-episodic. Can agent decision be made for different independent episode? That means agent, there is an environment, agent is performing some action, it leads to another environment. I mean that there is a change of environment. If each of this action and environment and action, if we say these are a separate episode for the agent, that means one episode is independent of the another episode, then we will say it is an episodic environment. Otherwise, we will say it is a non-episodic environment. Similarly, you have a discrete and continuous. If the number of actions and percepts fixed, then we will say discrete. Otherwise, it will be a continuous environment. So, if all the three properties inaccessible, non-deterministic, dynamic, and continuous environment, then we will say it is an open environment. So obviously, working with an open environment is really a difficult task. So when you design an agent, for a particular purpose, if the environment is open environment, then it is really a challenging work. So working on an open environment is complex rather than a closed environment. So these are the little bit abstract agent architecture. I am going very briefly. Let us assume there is a set of environment E where there is a number of such environment state. Assume an actions performed by an agent alpha, alpha dash, alpha double dash like this. The idea is there is a starting environment E naught. It performs an action alpha naught. It reaches you to another environment E1. That means the agent perceives the environment E naught. Then it performs an action alpha naught. It changes the environment from E naught to E1. Then from E naught environment, again, agent is performing another task. It should be alpha 1. Alpha 1 that will reach you to another environment E2. So it is a combination of environment and action. Environment and action. So we call it as a run. So run is a sequence of interleaved environment state and action. So in abstract agent architecture, we define it as a state transformer function, pi, which is a state transformer function, where you have a set of such run. Starting from one position of the environment, it performs a set of such run, and that leads to a new environment state. That is called state transformation function of an agent. Then what is agent? In most general sense, an agent is a function. So now we are bringing the more design aspect of an agent. So in most general sense, an agent is a function which changes. This agent is a function AG that changes from RAC to SC. That means you have a run state that sends an agent. Based on that, performs some kind of action, AC. So as a whole, an agent-based system is defined as R, which is a combination of such agent transformer function AG, and a set of environment. I'm not doing this thing. Okay. Now, there are some examples of multi-agent system. Agents have been applied to various applications areas. It starts from transportation, logistic, workflow and business process management, distributed sensing, information retrieval and management, electronic commerce, human-computer interface, virtual environment, social simulation, etc. Now, those people who are working on the software engineering, they can also use agent. Just like you have function-oriented software engineering or object-oriented software engineering, the same way you can treat agent as a software metaphor, where each component of the software is treated as an agent or kind of black box, which can sense some environment, perform some operation, and give some output on the environment. So a software or a general software system can be treated as a collection of such agent. There is another area where we can work agent as a tool for understanding the human society. Human society is very complex and computer simulation can be useful. There is a very good example of agent technology in social system simulation. Suppose the way COVID-19 is evolving from China to Italy, then US, Switzerland, Germany, then gradually to India. Can we design, can we simulate the environment for 130 crore people of India, and the way COVID-19 is spreading across the states, such that after 6 months or so, what will happen that we can see today only by computer simulation. So this is one of the example of computer simulation, so agent-based computer simulation for COVID-19, where what will happen for maybe another 6 months or 1 year, we can predict sitting today only. There are a lot of differences. Some people may think that agent is it same like distributed system? Of course, when we talk agent or multi-agent system, that runs on distributed system. Because when we talk about agents, more than one agents, it is definitely the agents are not physically located in one system, one centralized location. They are distributed across the network. And there is a need to interact with each other. So agent system uses distributed system, or multi-agent system uses distributed system, but distributed system does not mean it has an agent technology. I have already discussed agent versus object, so I'm saying agent versus expert system. Expert system is also some kind of intelligent system, but when you say expert system, it is more like a centralized system, and it has a huge knowledge base. It has a huge knowledge base, and based on that knowledge base, if you ask some questions to the expert system, it will respond. But this expert system may be an intelligence, may not be intelligent. It may not have social ability, it may not have proactive behavior as we have in the agent technology. Okay, so what is agent versus AI? When we talk about agents, agents grew up with the idea of distributed AI. When we talk about AI, artificial intelligence is mostly concerned with reasoning, problem solving, planning, learning, perception, action. Somebody asked the questions how neural network can be designed. So when we say simple AI is most like a problem solving, planning and learning, or perception and action. It has some huge knowledge base, or it can learn from the environment. By learning, it creates a huge database, and based on that, it can perform it. But when we talk about agent, it must have AI inside of it. But along with AI, there are some more things which doesn't have in normal AI. So when we talk about agents, along with the AI, it must have a proactiveness, that means the goal orientation and social ability, which the traditional AI doesn't have. So what is the problem with if somebody wants to work with agent technology? There are two aspects of working. One is agent design, another is society design. So agent design is something like a micro problem, and when you say society design, is something like a macro problem. So micro problem is agent design. How do we build an agent that are capable of independent, autonomous action in order to successfully carry out the task? But when we talk about multi-agent system, it is most like the society design. How do you design the society such that they can interact for cooperating, coordinating, and negotiating? So these three terms does not appear when you talk about traditional AI. So if you see this diagram, then this diagram shows the society design. Above all, you have interaction. Inside interaction, you have coordination. That coordination can be for competition, coordination can be for cooperation. If two teams are playing football, then they are in a competitive mode. There can be cooperation. They have some shared, they may not have shared goal, but the objective remains same. Both are trying to win, so they are playing with a win-win situation. Both will be winner. But when you say collaboration, collaboration is something like they have a common goal. They will take the share of the goal. So one of the example of collaboration is coalition formation or coalition government. When one of the political party does not get the sufficient number of seats to form the government, then they need to form an alliance. It's a kind of collaboration. Flipkart and Amazon, they collaborate with each other to do business in India, where Flipkart is an e-commerce company and Amazon supports the cloud. Okay, so I'm not going this thing. So I'm going a more interesting problem area. Issues in multi-agent system. In multi-agent system, we address questions: how can cooperate emerge in society design of self-interested agent? What kind of language can agent use to communicate? How can self-interested agent recognize conflict? How they can reach to an agreement? How can autonomous agents coordinate their activities so as to cooperate, achieve goals? And that needs the necessity to solve constraint programming, a constraint. It is a pervade our everybody's life, are usually perceived as element that limits solution to the problem we face. We are constrained with money, we are constrained with time. From a computational point of view, they reduce the space of possible solution, encode knowledge about the problem at hand, are key components for efficiently solve hard problems. Let us take an example. Multi-agent based meeting scheduling problem. A set of agents must come to some agreement, typically via some form of negotiation, about which action each agent should take in order to jointly obtain the best solution for the whole system. If you again recollect the example that I have started from the beginning, two persons agent interact with each other to come to a common agreement to find out the best possible time for the meeting. So that needs to a formal problem called distributed constraint optimization problem. Each agent negotiates locally with just a subset of other agents that are those that can directly influence his or her behavior. So formally, we can define a constraint network as X, D, and C, where X is a set of variable, set of discrete variable. D is a domain. It ranges from 1 to n. C is a set of constraint. So our objective is to choose the values of these variables from this domain such that it will satisfy all the constraints of the system. So X1 can choose one of the value from D1 to Dn. Similarly, X2 can choose from one of the values from D1 to Dn. Similarly, any X, that is the variable, can choose the values from the domain variable. And The objective is to satisfy the constraint. There can be two types of constraint. One is the hard constraint, another is the soft constraint. The hard constraint is at any cost, this constraint cannot be violated. There is a hard constraint. The hard constraint is this condition cannot be violated. But when you talk about the soft constraint, if a constraint is violated, the optimization value will be degraded. So for soft constraint, you can violate, but the moment you violate the constraint, the moment you violate the constraint, the performance of the system will be degraded. But when you talk about the hard constraint, at any cost you cannot violate the constraint. So there can be constraint satisfaction problem, there can be constraint optimization problem. If it is a constraint satisfaction problem, objective is to find an assignment of all those variables x1, x2, x3 in the network that satisfies all the constraint, that will satisfy all constraint. So that means you cannot deviate the constraint. Constraint optimization problem, you have to assign the values of x1, x2, x3 from this domain such that your global function will be optimized. Optimized in the sense, if it is a profit, then your profit will be maximized. If it is a cost, then you need to choose the values of x1, x2, xn such that the total cost will be minimized. Now, two types of decentralized approach. One is DCSP, distributed constant optimization, and constant satisfaction problem, and distributed constant optimization problem. So here it comes to the, when you talk about the distributed system, distributed constant optimization, there is a notion called agent. A DCOP consists of a constraint network XDC that we have discussed and a set of agent. Here, each agent A1 is responsible to choose the value of X from the domain D. Agent A2 is responsible for choosing the values of X2 from the domain D. So that means each agent is responsible for choosing the values of X. To choose the values of X from the domain, each agent must need to interact with other agent such that they can commonly reach to an agreement such their optimization value will be maximized or minimized. I mean, based on the optimization criteria. But both constant optimization and constant satisfaction, or distributed constant optimization or distributed constant satisfaction, is an NP hard problem. So some of the example is meeting scheduling problem. Some of the example is meeting scheduling problem. Is a constant optimization problem. Sensor network and robotics, target tracking. So this is a very common example of computer science that is called graph coloring problem. I think everybody is aware about the fact. There is a set of color, K color, and there is typically a graph. You need to choose the color for each node such that two adjacent nodes cannot have the same color. See, so this is the first diagram. The second diagram says this is a valid schedule, this is an invalid schedule because two nodes have the same color. So this is called constraint satisfaction problem, and this violates the constraint. So as I said, that can be constant satisfaction problem, constant optimization problem. The same problem can be modeled like this way when we talk about constant optimization problem. If there is no violation, the value is 0. If there is a violation, the value is -1. If there are 2 violations, -2. There are 3 violations, -3. So our objective will be to minimize, minimize the number of conflict. That will be our objective. We can put some more values here. If there is a deviation, if there is a violation in this edge, then the cost will be associated -1. If the violation in this node, then cost is -2. If violation in this node, -1, -3. So we need to find out the assignment such that this will minimize the violation. So if we choose this, then there is a 0 violation. If we choose this, then the violation is -2. Here, each node is associated with an agent who is choosing the color. And the interesting part is each agent can interact with only its neighbor. Each agent can interact only with its neighbor. Okay, so these two agents, any neighboring agents can interact with each other to come to a common agreement. That is called the social ability that we discussed. It can sense its environment, as you said. An agent can sense the environment that your neighboring agent, which color he chooses. So, since an agent can sense the environment, it can accordingly it can compute, it can change its environment, it can negotiate with its neighbor, other agent. Sure, another common example of is a classical problem of computer science. It's a meeting scheduling problem. In large organization, many people, possibly working in different departments, are involved in a number of working meetings. This person says better after 12 a.m. This person says its window is from 3 to 6. This person says this window is 3 to 5. So you need to find out the common duration of 1 hour such that everybody's constraint is satisfied. So here, the example of the soft constraint and the hard constraint can be starting meeting time across the different agents are equal. That means every one of the agents or every person of the stakeholder of the meeting should attend it. That means starting meeting of the different agents are equal. Meetings for the same agents are non-overlapping. That means I should not have 2 meetings at the same time, because then I have to leave one meeting. That is hard constraint. The soft constraint is agent may have some preferences. I prefer to have meeting in the morning instead of in the evening or after the lunch. That is my preferences. But that is not a very constraint. I prefer to have the meeting in the first half. After the lunch, I don't go for a meeting. That is my preferences. It is called soft constraint. So accordingly, you can model the problem as meeting scheduling problem. Okay, so these are my some of the research scholar who worked on this particular domain of multi-agent system in different applications areas. Okay, so these are the 5 PhD students who typically work on this particular multi-agent system, agent and multi-agent environment in different environmental settings. Thank you. So if you have any questions, I can take some questions. Hello. Hello.
Thank you, sir. Thank you for the wonderful speech. And it's time to take questions. Now we display the questions on the screen. And sir, please answer it properly. Sritadi, you can display the questions.
How sensor works? How sensor works? Uh, Sorry, I cannot tell the hardware architecture of sensor. I don't have that knowledge. Okay, so typically what I can say, sensor from the software perspective, sensor which senses the environment and it generates some kind of signal to the processor. That much I can tell you. I don't know the actual design because I am not, my background is not electronics or electrical engineering. So typically the hardware design of the sensor, I am, sorry, I don't know.
Okay, the next question.
Can you use an AI in automotive industry? Yes, it is there. It is already there. I told you that even today's the most cheapest car that we say is Nano, Tata Nano. That is also equipped with a MPFI fuel injector, multi-point fuel injector. That is nothing but it is having an inside and microcontroller chip that controls the ratio of fuel and air mixture. So you won't find the carburetor. Even today, all these bikes are coming. This BS6, they are also equipped with. They don't have carburetor. They don't have carburetor. They have an IC. They have a chip inside of. They can control the air fuel ratio. Is the most popular programming language used in AI? See, it depends on what type of design you are going. Typically, we use Python. So Python is because Python is rich with lot of libraries. You can easily have those libraries and you don't need to write the code even for all the thing. There are ready-madely available many things in Python. So you can use Python. Also, many of my students use Java as well, because in if you go for efficiency of the program, that means how fast your program is, kind of thing, or time complexity issues, then better not to go to Python, rather to use Java, because in Python when you go for Python, there are ready-made libraries that you will be using. So that may degrade in some aspect the performance of your system. For example, the time efficiency, time complexity, or space. It may take more memory. But if you go for Java, then your system will be faster, your program will be faster. But apart from that, whether you go for writing your own code starting from scratch, Java, you can use, of course, Python. But there are some other agent technology environment, for example, JADE, Java Agent Development Environment. If somebody is interested to write or design his own agent, software agent, or can do some kind of program like this, then he can use JADE. Another is, so JADE is Java Agent Development Environment. The entire this is entirely open source, and all the codes are available written in Java only. There is another platform called SPADE, Smart Python Agent Development Environment. Smart Python Agent Development Environment, that also can be used for writing the code, particularly the agent-based system. What is the constraint programming? Good. meeting scheduling, we can say it is a constraint programming. Meeting scheduling, we can say it is a constraint programming. Why? Suppose there are 10 people, they have to join for a meeting. Now, apart from this particular meeting, they may have different other meetings. So you need to find out a time such that two meetings of the same person should not overlap. That is the constraint. When the meeting will be scheduled, all the 10 people should be available. That is a constraint. Or rather, we should say these are hard constraints that cannot be deviated. What can be the soft constraint? Someone says, I slept in the late night, so I prefer not to schedule a meeting in the first half or in the morning. I will prefer in the second half. If somebody asks me, when you will prefer, I will always say in the first half. But even if the meeting is scheduled in the second half, I don't have any problem. But normally I prefer in the first half. As for this lecture also, when your HOD told me to organize things, I told her that I will prefer to have the webinar in the morning. I prefer in the morning. So she told, no, sir, this is a lockdown period. People are having a lot of other activities in the home. So if possible, you give it in the second half. I said, okay, no problem, I can give it to the second half. That is a soft constraint. That is a soft constraint. But the hard constraint, if I am not available today, and if you want to organize the webinar with me only on today, that cannot be possible. That is a hard constraint. Okay. Now, when we say so this is a very small example that I have given. Now, when you talk about this, is this slide visible? Hello, Srijita ma'am, is this visible?
Yes, sir, visible.
Okay, so here you see we have formally written the DCOP, distributed constraint optimization problem, with a collection of XDC, where X is a set of variable, D is a domain, and C is constraint. So X is a set of variable which can choose any values from the domain D. And the condition is it should always satisfy the constraint C. And we have a set of agents A1, A2, AK. Each agent is responsible for choosing the values of X. So this is a formal representation of distributed constraint optimization. Now, if you choose that your number of variables is huge and number of agent, of course, each agent is responsible for each variable. So as many number of variables you have, that many number of agent will be there. But if you have the domain is also very large and the constraint is also very large, then computing this or assignment of these values from x1, x2, x3, xn will be really a computationally hard problem. Okay. So that is the main challenge of the this particular research problem. So the application of this DCOP is you have sensor network, you can have meeting scheduling problem, you can have transportation problem, you can have delivery companies. Today, delivery companies is a very famous in everywhere, very popular in every state, every cities. So, what are the constraints? So you have to model the problem in XDCOP and then solve. So solving this problem is really challenging. This is called constraint programming. So it has a real mathematical aspect as well as a computational aspect of it. First, you need to model the application to the DCOP, and then you need to find out some kind of solutions. As this is a computationally hard problem, so getting the solution is really tough in optimum time. Is it true that AI is used in electronic to make a survey of consumer preference without the knowledge? Yes, yes. Uh, there was a famous example in USA. It is found that the person who buys diapers, the male who buys diapers, they also prefer to take beer. So beer and diapers, apparently you may find that there is no relation between the diaper and the beer. Apparently it looks like there is no relation between the diaper and the beer. But it is found that the persons who purchase diapers, they are normally taking care of their baby in the house during when the new baby is born, and they take leave from their organizations. So to spend their time, they purchase beer. So one company make a survey, and they decided to give some kind of discount. If a person purchases diapers, there is a 30% reduction in the beer. The sale of diapers and the beer will automatically goes up. That is a real fact. It happens in USA in one of the famous shopping mall. This shopping mall kind of company. So knowingly or unknowingly, there are a lot of information that are shared by the by your habit and behavior, which is unknowingly happening. A very informative session. I have a question. Is AI technology can help in? Of course. I have already given the example that today we are using. You may also use it. Grammarly. Grammarly is a software. Grammarly is a software that can be used for checking the grammar, English vocabulary corrections. So there is a free version of it. If you write an email, it can detect any error in your words, your vocabularies, in the grammar. It can also suggest you some better sentence of it. And if you can option, you can configure your Grammarly software to US English or UK English. That is again a philosophical questions. It's very difficult to tell yes or no, right? But of course, to some extent, you can get a result.
I hope there is no more questions.
Okay.
We have no time. Now I would request our head of the department to please give the vote of thanks. And Sujata, you can please proceed.
Thank you, Kajuri Bhattacharya. It is indeed a pleasure to accord the vote of thanks. I would begin by expressing my sincere gratitude to today's speaker, Dr. Animesh Dutta, for accepting our proposal to be the speaker of the day. Thank you, sir, for the wonderful lecture, and I am sure that your lecture will inspire many young scholars and students to venture on in future. My sincere thanks to our Principal Madam, Dr. Moushumi Chatterjee, IQAC Coordinator, Dr. Triparna Mojumdar, for their continuous support and guidance. I am thankful to our librarian, Mr. Joydeep Chando, for his effort in organizing this webinar. I am thankful to all the faculty members of Computer Science Department for their sincere efforts in organizing today's webinar. I am grateful to all the participants who have joined us today, without whom this webinar would not have been a success. In the end, my sincere apology to any interruption or inconvenience which might have been caused to anyone during the course of organizing this webinar. Thank you all once again and have a wonderful evening.
Thank you so much. Again, just last hello.
Yes, sir.
Yeah. So as the time was very short, already your HOD told me the time is 1 hour 15 minutes. So it was very short duration. So covering all the things was really tough for me. So as a whole, I have given a very brief overview of the agent technology, AI, and where possibly what are the research challenges or the problems of agent technology and multi-agent systems. Still, there are a lot of things. I mean, a lot of things to discuss, a lot of things to say. So if you people have any interest or any queries, you please do not hesitate to email me. I have the email. I have already shared my email ID. So you can ask questions over email. There's no issue. If you need any specific paper, research paper which we have in this domain, and if you cannot find out from the net, you just send me an email. I will send you the paper if you are more interested to go more detail about this work. Okay, thank you so much.
Okay, sir.
Thank you, all of you. Before we end, there is an important announcement. To get the e-certificate, it is mandatory to all of you to submit the feedback. Please log into our website and submit your feedback. Your e-certificate will be mailed to your registered mail ID. Thank you, all of you. This brings to the end of the webinar. Thank you.
Okay, thank you so much.
Thank you.